Okay, let's continue to explore inductively forceful arguments. We got our board here. Can't fit everything on the screen, but we'll keep moving on. Okay, so next is another argument. So this one's going to say a few dogs are friendly. Premise 2, Fido is a dog. We conclude Fido is friendly. Okay, now, is this argument inductively forceful? Well, unlike these, where the quantifiers was almost all or most, if all we know is that a few dogs are friendly and that Fido is a dog, it's not going to follow that Fido is friendly. It's not even going to follow that Fido is probably friendly because there's only a few dogs. That's our quantifier. So this is going to fall under the not inductively forceful, not valid option. But it's useful to just have it up there so we can see an example of an argument that gets into this category. Okay, so that was pretty straightforward. Let's move on. Premise 1. Okay, this one will be interesting. Many dogs are friendly. P2, Fido is a dog. Conclude, Fido is friendly. Now, is this argument inductively forceful? Now, we clearly know it's not valid, right? It could be that many dogs are friendly and Fido is a dog, but Fido is not friendly. So, not valid. Okay, but could this be inductively forceful? Well, inductively forceful means if the premises are true, the conclusion is probably true, where probably means over 50%. So does it follow that if many dogs are friendly and Fido is a dog, that there's at least over a 50% probability that Fido is friendly? The answer to that is no, not IF. Now, how can that be? Well, the thing is, many does not mean 50%. Or another way to put it is, many does not mean most. Okay, many does not imply most. Or many does not imply 50%. Here's another way to think about it. If we think about an election, say, it might be true that many people vote for one candidate and many people vote for another candidate. Okay, but it might be that neither candidate got most of the votes because both candidates might have still had over 50%. So let's say one person has 40% of the vote and the other person has 40% of the vote. Okay, and then 20% of the people just didn't vote. Okay, would we want to say that? We would want to say that many people voted for a candidate, the first candidate, and many people voted for the second candidate. But it didn't follow that like most of the people voted for any one of the candidates. Okay, so many does not imply most, and that's why this is not an inductively forceful argument. Okay, this is relevant to the homework that you did, so we'll talk more about it in the Zoom session. Okay, one last example, and it'll go like this. P1. Let's go back to all dogs are mortal. I keep wanting to say Socrates is a dog, but I'll put Fido is a dog. Conclude, Fido is not mortal. Now this one's interesting. Okay, if all dogs are mortal, Fido's a dog, it seems like it should follow that Fido is mortal, but this is saying is Fido is not mortal. Okay, but that's impossible. It's impossible for the premises to be true and the conclusion to be true, and that's what this is what we call incompatible. So it's a new category where it's just impossible for all three statements to be true. It's really what should belong up here. Incompatible. Okay, there's a probability 0. It's impossible for all the premises to be true and the conclusion to be true. And incompatibility also appeared in your homework, and we'll talk about that in the Zoom. Okay, so what we got with these different arguments is just a nice illustration of arguments that kind of fit in these different categories to help you understand the different types of inductive arguments, inductively forceful arguments, valid arguments, and arguments that are neither inductively forceful or valid, nor valid, and arguments that have incompatible propositions. Okay, with that, we'll start digging more into different types of argument forms, so that'll come about in the next video.